Okay, so we're giving you a handout. The first handout that you have, all right, the first page of it, are the different types of economies. All right, I'm not going to take time from class to go over every one of these. All right, but please take the time to read these. All right, traditional economy is basically like from olden times. There's not a lot of traditional economies left. Command economies typically tend to be less capitalistic and typically associated with socialist ideas, North Korea, communist, things like that. Market economies tend to be more capitalistic. All right? If you flip over on the back of it, you'll see a piece that says basically, command economies provide the least amount of economic freedom, while pure market economies provide the most economic freedom. In reality, neither really exist. Most economies end up being mixed. All right? So the mixed economies is just a mix between the three. More so a mix between command and market. And then you can see there the continuum. The United States tends to fall on about right here. All right? Whereas North Korea tends to fall about right here. All right? And then there's other countries in the middle. So like France and the UK are a little bit further away from being most economic freedom. So you could also get into the ideas too of where's the government involvement, and that's something we'll talk about, but we're not going to get to that part yet. All right, so deals with fiscal policy, and we'll cover that later on. It's a completely different unit. So like I said, just take the time to read over these because they are important and they do fit into the overall material. All right, so I had y'all reread Module 4, all right, on absolute and comparative advantages. All right, so that's what we're going to spend the bulk of today on. All right, so with absolute and comparative advantages, you've got input versus output. So what we have here is someone's going to have an absolute advantage and someone's going to have a comparative advantage. All right? And you've got input and output. All right, output problems are the state that the certain amount of product out of a given input. So it is the product you get out of something. All right, output is the product you get out. All right, so if I put a gallon of gas in my car, how far am I going to go? Yeah, so like I drive a Ford F-150, 1 gallon of gas is going to get me about 16 miles actually. All right, because I drive a newer one, so it's a little more efficient. Not a lot. And it's not. All right, how much gum can you get per dollar? Yeah, like one pack that has maybe, 10 to 15 pieces in it, depending on what you're buying? All right, so input problems state that it takes a certain amount of input to get a given product. All right, so this is the product that you put in. Output's what you're getting out. Input's what you're putting in. All right, so examples of this are hours to do a job. All right, apples to make a pie. How many hours do you think you have put into your high school career? A lot. So what's the end goal of that? Money, diploma, college, etc. All right. So input versus output. Any questions on those? All right. Absolute advantage. All right. Absolute advantage. All right. So for output problems, you look at if one nation, so the individual or company, can produce more output with the same resources as the other. All right, so in an absolute advantage problem, all right, for output, you look at if the nation can produce more output with the same resources as the other. All right, for an input problem, you look at who uses the least amount of input to get the output. Confused yet? Kind of. Okay. Good? Let me read you a different definition of absolute advantage. I'll just do it anyways. All right. So with an absolute advantage is producing a good or service if he or she can make more of it with a given amount of time and resources. So having an absolute advantage is not going to be the same thing as a comparative advantage. Whereas comparative advantages are producing a good or service if the opportunity cost of producing the good or service is lower to the individual or the people doing the producing.
Right.
All right. So with absolute, you could have output or input with absolute.
Right.
Same thing with comparative.
Right.
All right. So in this example, this is an output problem. So tons produced per hour. So if Ted is producing 70 cartons of milk in an hour, but only 15 units of cheese. All right. Nancy can produce 40 units of milk, but 45 units of cheese. How do we solve this problem? Anybody? Huh? Okay, a graph. All right, so we'd graph it. All right, we've got Ted, 70 units of milk to 15 cheese, 40 units of milk, and 45 cheese for Nancy. All right, so what does this mean to us? All right, well, you can see here that Ted can produce 70 tons in an hour, while Nancy can only produce 40 tons of milk in an hour. All right, so it makes sense that Ted should produce milk because he has the absolute advantage in milk production. On the other hand, who should produce the cheese? Nancy. All right? Because she can produce 45 tons of cheese to Ted's 15. Therefore, Nancy produces cheese. She has the absolute advantage in cheese production. Laurel?
Why wouldn't that be comparative advantage?
We'll get to that in a second. All right? Because with comparative advantage, if you look ahead, comparative advantage is one nation can produce a good at a lower opportunity cost than the other. So this comes into play with one nation or one individual having absolute advantage in both. All right? So we'll look at that in a second. But let's get down with this one first. All right? You make a good point. All right. So for an input problem, you look at who uses the least amount of input to get the output. All right. So hours built here. All right. Now remember, these are units. So car, tank, these are units. All right. So you can see that X, company X, 2 hours to build a car. Company Z takes 3 hours to build a car. All right? So therefore, who should build the car? X or Z? X. All right? X. It takes Z 1 hour to build a tank, but it takes X 2 hours to build a tank. Who should produce tanks? Z. All right? Comparative advantage. We ready to move on?
Yes.
All right. Comparative advantage. All right, so like I said, one nation, so the individual or company, can produce a good at a lower opportunity cost than the other. This comes into play when one individual, nation, or company has absolute advantage in both. All right, the output method here, you must look at the opportunity cost in order to determine the comparative advantage. So the person with the lowest opportunity cost should produce a good. All right, so we've got an output problem. All right, so we've got, again, we're looking at Ted and Nancy. Ted can produce 70 units of milk to 15 cheese. Nancy can produce 40 to the 45. All right, we already found that Ted has absolute advantage in milk and Nancy has absolute advantage in cheese. All right, so what about comparative advantage?
Nancy?
Nancy? You think Nancy?
Yeah, because she's getting like an average of both in one. Ted's getting
Correct.
a lot of milk.
She can produce both milk and cheese in the same time that Ted can produce milk and cheese. All right, so the comparative advantage would be Nancy, all right, because Nancy can produce both. Okay? Ted can only produce milk.
Aren't these like the ideals though? Like they wouldn't be able to produce 40 and 45 at the same time, right?
No, they could. That's what they're saying.
Because that'd be like outside of the efficiency here.
Correct, it would be. But we're talking about who could, this is now, we're taking that, but we're now discussing like the difference between comparative and advantage. So an absolute advantage, one company could produce, if you're good at producing milk, then that's what you produce. But then at the same time, if you could also produce both at the same time, why not do that? All right, we're not seeing that they're producing the exact same number. We're not saying 40 and 40. We're saying she can still produce 40 and 45.
So she can produce 40 tons of milk and 45 tons of cheese.
In an hour.
But on the chart, it's
On the graph or the chart?
I mean, on the graph. I'm kind of confused because if you go all the way up to 40, I thought then you can't produce any. If she produced 40 tons of milk, I thought she could not produce cheese.
Correct. All right, but we're looking at her opportunity cost.
Oh, okay.
All right, her opportunity cost is that she can do what with both? She can produce both. She has a comparative advantage because she can produce both with the lower opportunity cost.
So what if we were to say that like Ted's opportunity cost would be 70 tons of milk if he were to produce cheese? So isn't that higher than her 40 tons of milk if she were producing cheese?
If she was producing more cheese or less cheese?
Like if they were both producing cheese, his opportunity cost is higher than hers.
Correct.
But we don't look at that. We only look at like
Who's got the lower opportunity cost? Lower is better.
Okay.
So the person who has the lower opportunity cost has a better comparative advantage. Okay.
Yep. All right, so we know that the comparative advantage of this is Nancy. All right. In an input problem, you must first convert to an output problem and then determine who has the lowest opportunity cost. All right? So, again, dealing with cars and tanks. Company X, 2 hours to build one car, 2 hours to produce one tank. Company Z, 3 hours to produce a car, 1 hour to produce a tank. All right, so you'll notice then when one has an absolute advantage in a product, the other has an absolute advantage in the second product. They will always have comparative advantage in those products. So, here, 2 hours to do both. Here, 3 hours to do a car, but only 1 hour. All right, so who had the absolute advantage here? Company Z. All right. So we have to convert it to an input problem first. All right, so remember with an input problem, come way back up to the top, all right, you must look at who uses the least amount of input to get the output. The least amount of input to get the output. All right?
They're converting it to an output problem.
Yeah. So first look at it and then convert it. How do you convert this? You have to do fractions.
The common denominator.
Yeah, what's the common what's the common denominator here? Is it 6?
So in 6 hours, we do 3 cars and 3 tons. In 6 hours, we do 2 cars and 6 tons.
Okay. Sure. All right, so we know that. All right, who originally had the absolute advantage? All right. In what? In tanks. Oh, come on.
So does one always have an absolute advantage in one of them?
Mm-hmm.
We could just do this per hour. So company X, half a car per hour. And company Z, a third per hour. And then 1 per hour. Which one? Which one?
Or you could do 10 hours.
Which one is preferred? wants to go like per hour or million hours. Get on the calculator.
All right. So you've got company X. All right. So we're going to do all the conversions here. Talk about hours. All right. Half hour. All right. And then we take those numbers. I wish I had more room. And we times it by the 1/2 C equals the 1/2 T. All right. And you've got your 1C equals your 1T. All right. So then who should produce tanks? What'd you say? Z. C equals car, T equals tank.
Okay, how did you get that?
All right, so remember we have to convert it. So you're using hours. All right, so you have to convert it to an output problem and then determine who has the lowest opportunity cost. So if we're dealing with hours, all right, X, you've got a half hour,
Right.
all right, and then a half hour from T. You can take that. 3, how do you divide that out? Convert it to a fraction.
Wait, 3 is turned into fractions, that would just be 1/3.
Yeah, so you see what I did? I literally just converted these into fractions.
Right.
1/2, 1/3, 1/2, 1/1. All right, so here we are working with fractions. All right, so 1/2 car for X equals 1.5 T. 1C equals 1T, therefore Z should produce the tanks. You could, if you understand it.
Wouldn't it be 1/3 of car equals 1 tank though? Okay.
I mean, 1/3, you could do it that way, as long as you get that answer, depending on how you do math. We teach math different now, since Common Core came out. You think you can explain this different, Laurel? Did you understand it?
I can just look at the graph and see that there's one.
Can some of you look at the graph and just see?
Yeah.
Okay.
So you see it's lower for like 1.
Yeah.
2. What confused me is in the textbook that I'm reading, I was confused because I thought absolute advantage was who had the advantage overall on both sides, and the comparative advantage was who had the advantage with tanks and with cars, like, separately. I just misunderstood it and saw it backwards.
Yeah. And that's the thing, I don't like how they explain, they give you comparative first and then they talk about absolute. To me, it's easier to understand it if they talked about absolute first over comparative in the textbook. Also, I don't like their examples, but I didn't write the textbook, so. Yeah, you're right. All right.
So will company X have the comparative advantage? Will company X have the comparative advantage?
So, yeah. Z should produce tanks, but X would produce. So who has the comparative advantage at that point? X. All right. All right. All right, so our next example is Mike and John, corn and wheat. All right, so again, we're dealing with product per hour. All right, so Mike can produce 8 corn in an hour to 6 wheat. John can produce 2 corn and 4 wheat. All right, so how do you calculate this? Notice that Mike can produce more corn and wheat, so he must have what? He has what? Correct. He has both the absolute advantage in both. Does this mean he should produce both? No. All right. He should produce the one that he has the comparative advantage in and then trade for the other. So what's the one that he has the comparative advantage in? Corn. So he has absolute in both. All right, but he's got comparative in corn. So therefore he should trade wheat to who? John, yeah. Or someone else.
Wait, so they each in this have a comparative advantage.
Correct. Well, no. Mike has the absolute advantage. Mike also has the comparative advantage in corn, though, production. You do or don't?
I do.
Okay.
John kind of sucks.
Yeah. All right. So notice that Mike can produce more corn. You know, he has the absolute advantage in both. Does this mean he should produce? No. All right. So who has the comparative advantage? Mike. All right. Just know that you will never have a situation where someone has comparative advantage in both. All right. I put that in here. Do you see that? Is it written in there for y'all? Huh?
Is it impossible, or you just won't? Like,
You just won't ever have it.
okay.
If it's not written there, you should write it. Is it written there for y'all? All right, good. It made the notes this time. Sometimes I put things in here and then they disappear. All right. Input method. Apples. Apples to make 1. All right. So with our input method, for who's got the comparative and who's got absolute? Megan has what?
Susan
Susan has absolute power.
What? Tie?
Because how many apples is...
Oh, I'm reading it wrong.
Yeah, always happens.
And so is it a tie for absolute or
Is it a tie?
no?
No.
Because of the opportunity cost.
Mm-hmm.
Susan has the absolute in both.
Yeah.
Yeah.
And then
Susan would have absolute in both. And who's got the comparative?
Susan's got comparative
For pi, and she should trade.
Megan for the juice.
Correct.
They would just be trading 3 juice for 3 juice.
Yeah. All right. All right, so I've got some practice problems for you on your sheet. All right. for each of the following problems, identify if it is an input or an output problem, and then who has the absolute and who has the comparative advantage. All right, there's 6 of these.